It's always a fine line between robustness and stability while minimizing the risks, but also to bring a good product into the market.
Let's start with the basics. What was the goal and the development strategy for the arculee M?
So since 2021 we are part of the Jungheinrich organization, and we started into this marriage with Jungheinrich together with the arculee S. That was our first robot product, and since 2022 we have a lot of experience with the arculee S in the field. We get a lot of customer feedbacks. We get a lot of feedback from the sales organization of Jungheinrich, as well as feedback from the product management or portfolio management of Jungheinrich. And with that feedback, we decided to craft a new product increment, and that was the arculee M.
So what we specifically did at the beginning, we looked into the installed base of Jungheinrich, where we have all the pallet transports involved. And the arculee M is a clearly derivate focused for pallet transportation. So we had the advantage of looking in this huge database of installed projects, and this gave us the kind of an insight what kind of criteria when it comes to the use cases we need to fulfill in specific dimensions and center of masses and how much load capacity we need to transport. And here we were really able to tailor it exactly to this addressable market that we, from Jungheinrich perspective, can address and kind of find the sweet spot of where the arculee M should be, and also with this closing the gap, making the loop back to the arculee S, which the arculee S was not able to do before. And this gave us kind of an enhanced market share that we can address with the arculee M. I think that was the main goal at the beginning.
Can you introduce the arculee M as a system and explain how it's designed to play a key role in intralogistics applications?
So the arculee M as a system, we need to understand it from, let's say, the robotics part on the one hand side, which has on top a couple of peripherals. We call it the stations or the backpacks that we need for the pallet transportation. But it's also having the other side more on the fleet management perspective, where it's important to connect to the overall layers from the warehouse management perspective, or generally called the host systems. And here we also have a couple of components from Jungheinrich perspective, such as the logistic interface, for example, that can serve then as an abstraction layer to our fleet management. And the arculee M system is everything coming from the robotic side, the peripherals, fleet management, logistic interface to the host system.
From the customer perspective, what you get is actually a transportation from A to B, and that physical task is done by the robot. But if you are, let's say, replacing manual transportation against automated transportation, you also have to consider different kind of interfaces to the customer, and that is what you said. And the host system, where it tells us, okay, where do we need the transportations, where do we need anything transported, and that is what makes it like a bigger system with a lot of software components to it.
What are some common pain points in intralogistics that the arculee M aims to solve? Can you give examples of how it tackles these issues?
Logistics is always a cost factor, but on the other hand side, a very important enabler. So bringing goods from A to B doesn't make any more value to it, but nevertheless you need it at a certain kind of position at a certain kind of time. And that is where the arculee M kicks in. That means the arculee M is the enabler on the one hand side to do that transportation task, but on the other hand side do this as a on a very low cost basis, and doing this reliable on the 24/7 basis. That means the arculee M is really that substitute of a very cost-intensive logistics system, and doing this on a reliable basis.
Adding on to what Carlo said, it can be very difficult nowadays for companies to keep staff for 3 shifts, moving things back and forth. It's a job that very rarely people want to do. There are lots of people calling in sick in these positions very often, and it's really hard to keep the workforce. Plus they need vacations, you need a whole team, and the arculee M is the solution to kind of make sure that you always get intralogistics going with heavier loads than the arculee S could, and support the customers in bringing needs where they need it.
It's not only about replacing, let's say, people in that process. You also have in the past transportation systems like conveyors, for example. And conveyors are very reliable, they're very fast in transportation of things or carriers, but they're very inflexible. That means if you need to change a source and a sink, for example, that comes with a lot of costs. So you need to disassemble, you need to reassemble, you need to have a lot of infrastructural things to do. And that is where an arculee M system is way more flexible in changing over time. That means the initial setup or the layout that you would start a project might be completely different once you get further in time with the project.
And maybe to add on this, there are actually a couple of reasons why our customers want to automate. One is definitely cost. So over time, they want to amortize with the investments they did in automation, have a scaling effect, and in the end be more cost effective. That was the main reason in the past, but in recent times it kind of changed also. Because labor is so hard to get in these days. So one of the main drivers nowadays actually for automation is that the customers, they don't get the labor that's actually needed to perform manual tasks. And then in order to be productive still as a company, they have to invest in automation in order to maintain their business.
What are the primary use cases for which the arculee M was developed?
The arculee M tries to improve the solutions for underload carrier transport, or meaning the arculee will drive underneath the load, lift it up and carry it around in the plant. Its main focus is intralogistics, of course, transporting goods either from people to storage, including narrow AOs with highly stacked items. In conjunction with other automation solutions that Jungheinrich also provides, to be able to efficiently move goods around in parallel.
So the arculee M was from the very beginning clearly in all aspects tailored for pallet transportation. And in specific, we want to approach, for example, very narrow aisle applications. So these are these high rack storage solutions that you might know, where Jungheinrich is already a very big player, and we have seen a big chance in the way how we transport the pallets into these high rack storage solutions. And yeah, we have the key advantage that we are connecting here two automated trucks from Jungheinrich and Arculus together, and as Jungheinrich we have then the advantage to deploy this as one overall system. But yeah, that's only one example. In general, the arculee M is, as I said, clearly focused on pallet transportation, and we can apply this almost everywhere in warehouses and productions where pallets needs to go from A to B. This always happens in such kind of stations that pallets can be picked up and shuffled.
How flexible is the new robot for specific client needs and requirements?
The core idea was to balance out basically those two poles. That means we created a physical platform with the arculee M that has all the main, let's say, complex functionalities inside. That means localization, navigation, all the lift activities that carriers that load, etc., etc. And based on this, we have this so-called backpack system. That means based on the different load carrier types, we can apply a different backpack to it. And with that, still keep the system flexible for different applications. To add to this, we also redesigned the software layer on top of it. That means we concentrated very hard on easy deployment. We concentrated on robustness in the system itself. That means, for example, to create a layout where we are able to use as much as robots as possible to create a high amount of throughput through the system and make it as deadlock possible as.
When we look into the market, we see a huge variety of pallets out there. And the aim was from the beginning on that we stay flexible. So the question was, how can we ensure this? Because we don't want to develop each and every time for every kind of load carrier a different product. So the idea with the arculee was to keep all the complexity of the robot itself in the platform, in the robot itself, and have then an interface mechanically and electrically to the so-called backpack, which is then kind of individual to the load carrier and can even be configured individually.
This allows then for our software in general to be mostly standard and basic, which is again easy to test, easier to ensure robustness and performance, while still allowing for variation on customer side for the flexibility of the backpacks and with the support of the logistics interface on top.
Let's talk development. How are technical specifications and performance benchmarks determined for a new robot?
In general, when we start the development for a new robot, the first step is to take a look into the market. We see which point of the market we want to cover, what is our target use case, and from there, of course, we know the competition, we know what they are doing, and we look back into our technology stack and see, okay, what do we have? How can we use what we have to cover the use case that we want to cover, and what modifications are required. It's always then an interesting challenge to go through these modifications. Of course, the more modifications you bring into the system, the more complexity and risks you add for the development and to achieve the deadlines, while of course you want to have the most performant robot at the end to bring the most throughput that you can to the customer. So it's always a fine line between robustness and stability while minimizing the risks, but also to bring a good product into the market.
We call what Iuri just mentioned the platform approach. So our idea is to develop in a vertical manner the products or the so-called platform, which means we have really access to, from the high-level software to the lowest microcontroller and low-level software, the possibility to integrate everything in one holistic system. And when we develop a new derivative, we rather look into the use cases and identify for which use case, in this case, what kind of requirements or product specifications are relevant. And then, based on this, we can then take our platform approach and stretch it and scale it in the ways that's needed. That might be we add additional peripherals or sensors. That might be we are stretching the platform from the physical side. So it's always either mechanics or electronics or software where we need adaptations. But we have the advantage of always basing this on the platform that we already have and the know-how that we already have, and then scale it up to the new use case that we want to target.
What you want to achieve is to craft, let's say, a first minimal viable product with a certain kind of specification that is able to go to the market in a very short time. And with that, you ideally get to the customer, and then you really find out, okay, what is really demanded by the market, and from that on you iterate even more with the product. So basically what you want to avoid is, because when you start thinking about a product, you do this based on hypothesis. And you want to check this hypothesis as soon as possible in the process to correct assumptions that you have done in the beginning. You want to maybe find out if the hypothesis doesn't fit to a market hypothesis that you maybe have in mind. And with that, you actually tend towards a product that is basically the final product in the end.
Finally, let's talk about evolution. How does the arculee M signify an evolution from the arculee S regarding functionality and benefits?
Looking at the arculee S, we had a clear target use case of table transportation. The reason was that back then we had major projects in warehouse applications, and usually it's a matter of fact that you have to shuffle tables from A to B. So this was what the arculee S was made for originally. But then after the acquisition with Jungheinrich, we discovered the field of pallet transportation. And our first project with pallet transportation was done with the arculee S. And actually it worked well. We made a good solution, brought a good solution in the market. But while bringing it into the market, we already saw limitations. So we had kind of limitations in scaling up, for example, load capacity and load height scenarios. And when we looked in the same time in the database of potential new projects, we identified that there's a gap in the portfolio because we cannot go for the higher ones. And that was actually the initial idea why arculee M was born, to close this gap and also fulfill higher load capacities in terms of the mass itself the robot can transport, but also the load height it is able to transport.
The improvements also don't stop there. As we were talking in the previous question, robotics is kind of a living product, at least the way we see it. And another improvement that we did based on field feedback was to level of serviceability of the robot, so how easy it is to provide service to the robot and maintenance. The robot has several safety critical features to make sure that it's safe for operation around people, and these features, for instance, must be tested every year. So with that thought in mind, several changes were made to the robot to make it easier for a service technician to work on it, meaning at the end of the day a reduction of cost and improvement of the product in general.
In specific for the arculee M, we divided the entire product in a couple of sub-modules coming from the mechanics, such as the lift, the active lift, the passive lift, also the electronics module, the peripherals. And with this modular approach, it's actually first very easy to build up the robot. So from a production perspective, we decreased the amount that's necessary to build up the robot significantly. But also from a maintenance perspective, it's much easier to access the components, to get them in or out or service them. And yeah, that was one of the major goals that we also had for arculee M that we achieved quite well.
How has field experience from the arculee S shaped the development of the M model?
The arculee M inherited a lot of core ideas from the S already. That means, like we talked about the modular assembly concept, and also about the central robot control unit, which is basically a closed electronics unit that we developed by ourselves that inherits all key electronic features to basically craft the whole autonomy layer. And this is something we also adapted for the arculee M, and what we basically concentrated now with the arculee M, besides this really core features on load, etc., was really to enhance the capabilities in terms of localization and navigation. So we put a lot of effort in software development on that side.
So when we look at the arculee S and all the components that are embedded in it, we have learned in the field what components work well, also with which we might have issues or which are not, let's say, from the supplier perspective, let's say in a different range. And these were all learnings that we were transferring into arculee M. So everything that worked well, which is kind of pre-validated from arcules, we took over in a same or similar way. And let's say all the other things that where we have seen improvements, we had the chance to improve them in the arculee from the component perspective, talking about actuators, sensors, but also from the software perspective. So every modules that we wanted to change, we changed.
Okay, that was it. Thank you, Carlo, Romano, and Iuri for joining us. See you in the next video.